Thanks for joining me for another edition of Math with McComish, even though you really had no choice. So today we're going to be subtracting polynomials symbolically, so just the numbers and letters with no models. So when subtracting a polynomial in brackets, you're going to add the opposite. So you're going to change the subtract to an add, and then every sign inside the brackets needs to change to the opposite sign. So it's like using the integer rules for subtraction. The integer rules, when adding two negatives, the answer will be negative. When adding one positive and one negative, the sign will be from the larger number. So we're going to take a look at some examples like the one seen here. So let's look at this one here. So we're subtracting here. So what I can do is I can actually change this to a plus. Okay, but if I change it to a plus, I need to change every sign in here. This one was a positive, so I change that to a negative. This one's a positive, so I change it to a subtract. This one's a subtract, so I change it to a plus. And now I just use my adding rules for that. So remember to do like terms. So 12m squared plus a negative 8m squared is actually positive 4m squared. Negative 4, and it says subtract, but you look at it like a negative. Negative 4m plus a negative 3m is actually negative or minus 7m. And then positive 7 plus a positive 3 is positive 10. So basically I'm just changing it to an addition question by changing the subtract to an add and then every sign of the ones in the brackets. So let's do some more examples here. Change that to a plus, this becomes a negative, this one becomes a positive, this becomes a positive. I do not change my first polynomial at all, it stays the same. So negative 4x squared plus another negative 1x squared is negative 5x squared. Negative 3x plus a positive 4x, using integer rules, would give me positive x. And negative 11 plus a positive 15 is a positive 4. So using my canceling rules properly, that's what I would end up getting. Okay, let's do this one. Make sure that you use the same exponents for each one, so those go together. But first it subtracts, so I'm going to change it to a plus, change that to a negative, negative, positive, positive. And now I just do an addition question. So 4a to the exponent 4 minus 3a to the exponent 4, or plus a negative, is just a to the exponent 4. This negative 3a exponent 7 is the only one in there, so it remains the same. So usually I could just put it up in front, because that's often how we write them. This a, well, I have an a to the 1 here. I have an a cubed here. Let's just put in my a cubed, so nothing plus a negative 2a cubed, so that 2a cubed just stays in there. Now I have an a plus a positive 4a, so that would give me a positive 5a. If you want to cancel these out as you do them, you can do that, just so you don't get confused. Negative 12 plus a positive 4 is a negative 8 or minus 8. So that would be my subtracted polynomial. I'll do one more for you. So this is 10q cubed minus 7q plus 6q squared minus 5. So I take that, I'm going to change this to a plus. Okay, this one looks like it was a negative, so I'm going to make it a positive as well. Positive, negative, negative. Okay, make sure you combine like terms. So I'm going to do my 10q cubed plus just another q cubed, so that will give me 11q cubed. Notice how my exponents never change when I add or subtract. Okay, now I'm going to do, so that one's done. I'm going to do this one because it's the next highest degree. 6q squared plus a negative 2q squared is positive 4q squared. So I'm done with those. Now I have negative 7q plus a positive 3q. So that would give me minus 4q. And finally, negative 5 plus negative 3 is minus 8. All right, I want you to pause the video, try these ones on your own, and in a minute I will show you the answers to see if you got them correct. Okay, here are the solutions to those. If you did not get that, find me to ask me or go back and try them again until you do.